So today is Feb 15, 9 p.m. and I'm recording the third module for FS152, which is Thermodynamics. So hello and welcome back to everyone. Good evening from my perspective, but you may be watching this at another time of day. It's probably March right now where you are. So most of you do not like to hear the word thermodynamics. It brings up pretty much not so good memories of maybe Chem 17, or I don't know, baka high school pa lang tinatakal niya na to and may phobia na kayo sa word. But don't worry, because we'll approach it from a somewhat more practical perspective. So I hope you enjoy because we'll be studying this along with its important applications for the next 3 weeks. Okay, so nakakatakot yung salitang thermodynamics, but let's try to break it down as usual to its origins, which is apparently two Greek words for heat and power respectively. So you combine them, you get the power of heat as a sort of meaning, di ba? And of course, when we hear the word dunamis, para siyang dynamite kasi yun nga yung root word kung saan nanggaling yung salitang dynamite or yung dynamic, dynamo, mga ganon. Simply put, thermodynamics was defined as science that deals with the relationship of heat and mechanical energy and their interconversions, and thus this is actually the cornerstone of one of our major topics in food engineering, which is energy balance. So obviously when we're dealing with thermodynamics, medyo malawak siya kasi anything that is related to heat and mechanical energy will be covered in this session. So I hope maging friends tayo with thermodynamic throughout this lesson series or module. So with thermodynamics being defined, you might want to think, ano naman ang kinalaman nito sa food processing or sa food engineering? Well, malaki at marami kasi sa food processing, you usually either heat or cool, and you use mechanical energy in a number of creative ways. Anything from yung mga motors, conveyor belts, or whatever that rotates to do something related to the processing of your food, up to, of course, the various heating and cooling stuff that we do in the process of making our food, especially in large quantities. So, yung simpleng pagluto nyo ng instant noodles, o paghalo nyo ng soup, or those that picture in the middle ng parang ari ng mga some kind of equipment, mga tangke na may pipe, those are actually large-scale compressors. Think of the thing inside your air conditioner or refrigerator, but make it 100 times or 1,000 times bigger. And yan yun. So that's most likely from a facility that has a very large cold room, like let's say a cold storage warehouse. So lahat yan may kinalaman sa thermodynamics. So we have to start by looking at the thermodynamic laws and then try to relate them to everyday phenomena, and then add some way of quantifying heat and energy. So similar to mass balance, thermodynamic is governed by laws, and the first law, much in the same way dun sa conservation of mass, is the law of conservation of energy. Siguro naman naisip niyo na ito noon pa, but of course energy can neither be created nor destroyed, but only transformed from one form to the other. So the pictures that you can see there, they represent yung interconversion of mostly electrical energy into light, mechanical energy, invisible waves, light waves, and then the conversion of solar energy into light, and then mechanical energy that propels wind in the case of the electric fan. So all of those energy transformations are used in the food industry. And minsan siguro papaisip kayo, kung pala energy is neither created nor destroyed, then why do we pay for electricity? Eh, hindi naman pala siya nakakreate or nadidestroy. So yung nakokonsumo mong kuryente apparently is just saying that you're converting electricity into other forms of energy and paying Meralco for it. Well, although energy is converted from one form to the other, meron din tayo of course tinatawag na entropy nun. Halimbawa na lang kung ikaw ay nag-burn ng fossil fuel, it's not as easy to turn back that combusted fossil fuel into fossil fuel again. And that's what makes it a limited resource. The energy was converted, but in the process of converting that, you made a chemical reaction that is not very easy to reverse. So to give you an idea on just how wide the scope of thermodynamics is, even including fluid flow, which is another topic, so kindly watch this video link on hydropower applications in Nepal. Okay, so ano naman yung practical implications ng thermodynamics sa buhay natin? Well, actually, marami. So similar to mass balance, we also have an equation. So the change in energy in a system is equal to the difference between the energy input and energy output. So most of us have cell phones, di ba? And actually, when you charge your phone, the change in the amount of charge would depend on how much power you're putting in through the charger and how much power it's using up, assuming you're using it while charging or you're charging it while it's on and it's consuming a certain amount of power. Therefore, that means that the energy that seems to have been quote-unquote lost is actually just converted from one form to another. So wala talagang totoong energy losses, so to speak. So we just have to account, similar to mass balance, you have to account for where the energy went. So generally, ang pinaka equation yan, of course, alam natin from physics, is related to heat and work. When you expend energy, you either produce heat or do work. So in the case of your phone, actually, when you're charging anything or even your digital devices, any heat that comes out no pag tinatch mo tapos higher than room temp yung device mo, that's energy that you draw from the system, from the battery or from the outlet that did not become useful work no, to run your processors, your screens, and so on. Well, ganun din naman actually sa katawan ng tao, similar sa mass balance. The food that we eat has energy in the form of calories, which our body uses up. And if we obtain more energy from the food that we eat than what we expend, so nasa-store yon as energy storage, which in the case of our bodies ay may kahalong mass. No, yung mga fat sa katawan mo, usually, no? So anyway, there. So actually, you can use the energy balance for biological systems. You can use it for mechanical systems. But of course, we're gonna limit yung calculations natin to those useful sa food processing. So case in point, lahat naman siguro tayo ay gumagamit ng kuryente one way or the other, and it has been extra important for us lalo na sa remote learning. Kasi kung wala tayong kuryente, we cannot connect to our digital devices and do remote learning. So you've probably noticed your electricity bill kung medyo may pakialam kayo sa bahay ninyo or saan man kayo nakatira sa magulang ninyo sa mga gastusin. Mapapansin nyo na energy is computed in kilowatt hours. That's another fancy way of saying joules, no? Or kilojoules. And usually, nakatay yung price ng kuryente sa amount ng kilowatt hours. In reality, actually, medyo may konting variation yan. Hindi siya yung fixed na 11 pesos per kilowatt hour. No, may tier effect siya na if you consume smaller amounts, you usually pay a smaller cost per kilowatt hour as well. Parang tinatawag nilang subsidy Okay, this is to discourage you from squandering the limited resources natin sa pag-generate ng electricity. And siguro, pag mapapansin sa bahay, kada appliance nyo ay may rating in watts about how much power it's expected to consume. Your cellphone, charger, your laptop, your electric fan, your TV, may mga sticker yan lahat sa likod na makikita nyo how much power they consume. And actually, yung power na yun ay related din naman sa power na pinaproduce ng gasoline-operated vehicles. They could be converted into the same unit for some sort of comparison so that we could do the energy balance, so to speak. Alright, so normally kung face-to-face tayo ay naglalaro tayo ng game. Pero ito, pwede na lang siguro in a piece of paper, try to pause and write down your answers as to how much power in watts you think these devices consume. So this one is a cell phone charger. Alright, so yung kanina, that small charger was a 5-watt charger. It's a first generation charger, usually pang Android, ganon. So, yung mga bagong charger ngayon, mga 18 watts, 20 watts, all the way up to around 35 watts, which is actually a charger na for a small laptop. Because newer phones right now have larger batteries for their larger screens and more powerful processing. Anyway, segue lang yun. We'll now proceed to the second law of thermodynamics. There are two statements here. I'll read it to you and try to give a simple explanation. So first, no process is possible whose sole result is the removal of heat from a reservoir or system at one temperature and the absorption of an equal quantity of heat by a reservoir at a higher temperature. So, ibig sabihin lang po nito, well, we know of course that normally yung transfer of heat is from hot to cold. May temperature gradient ka. This statement is not saying na imposible yung reverse from cold to hot. Pero na kung magta-transfer ka man from cold to hot, hindi niya ma-absorb lahat ng energy or heat na yon. So, in short, you would have to, parang sa refrigeration to when you're transferring from a cooler place to heat from a cooler place to a warmer place. Meron kang i-expend na energy in the process na hindi mo matatransfer doon sa hot temperature. Okay, and the second is no process is possible whose sole result is the abstraction of heat from a single reservoir and the performance of an equivalent amount of work. So what this simply means is that even though there are ways to use heat to produce mechanical work, let's say kapag ikaw ay nag-init, di ba, ng water sa isang kettle, the molecules the heated molecules move around, and that is actually doing work because you're moving water molecules around. And in reality, yung steam nun, you can use it to maybe run steam turbines and therefore do mechanical work and run anything from a steamship to a train or what. Pero yung amount ng heat, which can also be measured in joules, na i-release mo, hindi yun 100% magiging work. So if you had 100 joules of heat, there is no way na magamit mo yon to do 100 joules of work. Parang ganon. Okay? Okay, so ano naman yung implications ng second law of thermodynamics? So first is that the heat transfer, of course, obviously, as we know from experience, is from objects with a higher temperature to objects of a lower temperature. And that the reverse, although possible, because that is the basis for refrigeration and air conditioning, could not be done 100%. So, kung gaano ka daming energy yung na-expend mo, hindi lahat yun ay matatransfer mo to the system with the higher temperature. So in refrigeration, that simply means that you have to do work to move heat in the unnatural direction of cold to hot. And next is that even though you can use heat to do useful work, not 100% of the heat can be used to do work. So in essence, parang may heat pa rin na matitira.